You ever ask an AI a question that seems, pretty simple, but it just completely misses the point? Well, today we're going to dive into a huge shift in AI architecture that's teaching these systems not just to find stuff, but to actually think and reason with it. So here's what's on tap. We'll start with why current AI search hits a wall. Then we'll look at a much smarter way to build these systems and see how it actually thinks. After that, we'll get into why this is such a big deal, and of course, what challenges are still out there. All right, let's jump right in with the core problem. Why is it that these incredibly powerful large language models can feel so limited when you need them to connect the dots? Take a look at this question. On the surface, it seems totally straightforward, right? But for most AI systems, this is a nightmare. See, it's not a one-step query. It needs to find a list of people who used to work at Google and then cross-reference that with a list of startup founders. That simple connection is exactly where things fall apart. And this really gets to the heart of it. Most AI today relies on what's called Retrieval-Augmented Generation, or RAG. It's basically a fancy way of saying it finds text that sounds similar to your question. But what we actually need is relational understanding. The AI needs to get how different facts are logically connected, even if they're not sitting right next to each other in a document. This creates what you could call the flat context problem. The AI just grabs these huge, messy chunks of text and crams them into its working memory. It's noisy, it's inefficient, and worst of all, the answer it gives you is a total black box. You have zero idea how it got to that conclusion because there's no paper trail. So, how do we fix this mess? Well, we do it by bringing in a smarter setup with two key players that are about to completely change the game. First up is the knowledge graph. Now, this is not just another database. It's more like a structured map of facts. It organizes information into nodes, think people, companies, ideas, and edges, which are the actual relationships that connect them. Honestly, the best way to think about it is like a social network for your data. It knows that Sundar Pichai is the CEO of Google. The relationship itself is a piece of data, and that's absolutely crucial. Our second key player is Agentic AI. And this is a massive leap. An agent isn't just spitting out text. It's a system that can actually reason, break down a problem, make a plan, and then use different tools to get the job done. You can just think of it as an AI project manager. It gets a complex request, and instead of trying to tackle it all at once, it smartly delegates the right job to the right tool. It's the brains of the operation. So you've got the knowledge graph, the map of facts, and the agentic AI, the project manager. How do they actually work together? Well, they do it in this really cool dynamic cycle called a reasoning loop. Here's a peek inside the agent's head. First, it deconstructs your question into smaller pieces. Then it makes a strategic choice. Is this a question of hard facts? Okay, let's use the knowledge graph. Is it more about general context? Then let's use the vector database. It runs the query, grabs the data, and this is the amazing part, it analyzes the results. If something looks off, it can actually self-correct and try a different plan. So what's happening here is a fundamental shift in what the LLM does. It's not just a writer anymore. It's getting a promotion. It's becoming an intelligent router, a planner. It's the conductor of the orchestra. Okay, this all sounds really cool in theory, right? But let's get down to brass tacks. What's the real-world payoff? Why is this new architecture such a game changer? Let's just start with a number. How about 3.4x? That's the measured gain in accuracy you get when you ground an AI's answers in a knowledge graph. In a world where AI mistakes can be really, really costly, that's not just an improvement. That is a massive leap in reliability. Let's just put these two approaches side by side. Your traditional RAG is swimming in unstructured text, which means you get very little explainability. The knowledge graph approach, on the other hand, uses structured data, which unlocks complex reasoning and gives you a fully traceable path for every single answer. Now, the trade-off? As you can see, it's a heck of a lot more complex to set up. So let's just boil down the advantages here. First, it massively reduces AI hallucinations, because answers are tied to actual verifiable facts. Second, it allows for multi-hop reasoning, connecting the dots to find insights you'd never see otherwise. And maybe most importantly, it gives you true explainability. This is what finally makes AI trustworthy enough for high-stakes fields like finance, law, or medicine. But, it's not all a walk in the park. We have to be realistic about the hurdles that are still on the road ahead for this technology.
Building these things is hard. Just wrangling all the data is a huge task, and making sure it runs fast when you scale it up is another major headache. But the biggest barrier might just be the expertise gap. Finding people who actually know how to build and maintain these systems is really tough.
But looking ahead, the vision is just incredibly exciting. The next big thing is the self-evolving knowledge graph. Imagine an autonomous system where these AI agents aren't just using the graph, they're actively making it better, updating it, and improving it over time. It becomes a living, breathing resource that gets smarter every day.
And really, when you boil it all down, the biggest shift here isn't just about getting better answers. It's about changing how we think about AI trust. We're moving away from just looking at the final answer and asking, is this right? Instead, we're starting to evaluate the process and demand to know, how did you get here? It's a fundamental change from trusting an output to finally being able to trust the process.